So it's recording now. So basically today we're going to talk about Numpy and Matplotlib. And tomorrow we are going to talk about Panda and machine learning, and also we're going to talk about our final project on day 4. And so I'm going to do a brief introduction about Numpy. So first, Numpy is a built like Python does not have a built-in multi-dimensional array. Also like in syntax supported, and also we have kind of talked about list yesterday. Numpy have similar function to the list, but as what we have shown yesterday, I think also I start the video about me. Okay, so also as what having shown yesterday, so you can see that when you need to do the list addition, it's simply gonna to repeat the list, and when you're trying to do list multiplication, it's going to like repeat that segment of the list for several times. It's not going to help you in the way of math or like in the way of linear algebra. So we need NumPy, and also NumPy is like really fast, and it's really fast, really easy for the n-dimensional array. And NumPy have different data types you can find in that, but basically I'm going to show you how to import and how to do the basic linear algebra function and also the basic statistic functions. So I'm going to share my IDE, and for those who have been here yesterday, so I think you have already know about how to import that. So if you haven't, then you can go over the videos which I have put in my document. But we have like talk about after you have like installed that, what you're going to do is that you're going to import that. So basically it's import numpy as MP. And also we're going to talk about Matplotlib. So you also need to install Matplotlib, but after you have installed that, you're going to import that into the file that you write. So it's Matplotlib py.plot, import Matplotlib py.plot as plt, because you're going to call it with plt instead of write this really long name. So this is easy to call, but first we're going to talk about NumPy. And so I'm also going to talk like mostly refer to the syllabus or like the teaching materials I have prepared, so that we are not going to lose any part. But also like probably some message I might not be talk about, so you can just look at that by yourself. And the first is I'm going to show you about how to create a NumPy array, and I'm going to talk about like first just create a array with the basic NumPy literal. So basically what you're going to do is just NumPy dot array, and since this array is kind of like the list, you need the bracket, and you can put like different element in it, so like 1 2 3 4. But something that is different from the list is that list you can put different data type into the list, but array you can only put the same data type. So you cannot do something like this, like 1 2 3 and then Python. So you can see like it has like reform. This is like reformat, so it just like give you the space. But basically you cannot do like 1 2 3 and Python. We can run that to show what it will print out an error for us. So print that out. Probably it can print out successfully, but this is not like the right way of doing so. So this print out successfully, but probably we can try like this to see whether it can be successful or not. Oh, so yeah, so like you can print out that successfully, but something that you can see is that it actually has cased our int into the string instead of an int. So you can see like surrounds this int, you have like quotation mark, which means that it has been converted into a string, which means that for an array, you need to have the same data type. So we can put a list to see if it will cast the list into a string or into a list into a number, or it would just throw an arrow. So we can try that. So basically it's throw an arrow because it says that creating an empty array from rect nested sequence, blah 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 blah, is not like it's deprecated. So in an list you can do this, which I have talked about it yesterday. So my list, I print out this, it's completely fine. But in an array, you cannot do that. So I'm going to print that out. So this is fine, but for an array, it's not fine. And yesterday we have talked about like how to do the list addition, what's the effect of it. So basically we have another my list 2 equals to 1 2 3. And we have already saw that it's like a concatenation of it. It's just a repeat that. It's just concatenate together. But now we are going to create an array, which is Numpy array, and we can just convert a list into array, cast a list into array by just put the list into the parentheses of Numpy array. And also we are going to have our array 2, which is just cast our list 2 into our array 2, and we can print out our array plus array 2. So we can try this out to do a comparison of them. Numpy.array, sorry, I shouldn't write I should write the full name of it. It's not like I'm creating array. So like for the list, you can see it's just a concatenation, but for the array, it's actually have to do the mathematical addition plus a 1 together, 2 together, and 3 together. And what we can also do is that we can try the array multiplication. So we can time array by 2, and also we can just time our list by 2. So for the list yesterday we get 1 2 3 1 2 3, but for the array we get 2 2 4 6, but also we can do like 10. We can also do 10. So my array is going to repeat that for 10 times, but my list is going to repeat that for 10 times, but array is going to do the mathematical multiplication for each number in the array. And also we can see like what's the effect of divide my list 1 by my list 2, and also we can do the array 1 divided by array 2. So list is showing us an arrow because we don't have like list division, but for array we have division. So we can copy this out and we can print out. It's going to give us 1 1 1 because 1 divided by 1 is 1, 2 divided by 2 is 2. So also we can also like try float division. It should be the same. But because it's float division, so it takes the int. It's not like a 1 point that symbol. It's a like float or double. But now it shows that this is the int. And on first part of our array, mathematical is just division and addition. But array have much more. It have our like our matrix multiplication, and it will also have dot product, and also it have our cross product, and our array just have our plus, minus, multiplication, and also have our division. So you can also try that out with like our subtraction operation, but what's the most amazing part is try that with our dot matrix. So first we are going to create a matrix. So basically can do numpy array, then we need a bracket for the array to be in, and then you can put the inner dimension by create another bracket, and that's like our inner dimension. If we create like more bracket in it, it symbols like more dimension. So now it's not like in the one dimension array, but now it's already like two dimension. And now we can also have another array. I'm going to quit the Slack. It's sending me notification, which is a little bit annoying. And we can do the same. So this is our outer dimension, and in the inner dimension we can put like 5, 6, then put 7 and 8, 7 and 8. And what we can do, first we can still like try just do a simple element-wise multiplication, just a times b. So it's going to be like 1 times 5 equals to 5, and 2 times 6 equals to 12, and 3 times 7 equals to 21, like this. This is just the most simple element-wise, but what we can also do is that we can do the matrix dot production. So that basically, if you want to do a matrix dot products, you can do add b, just a dot product b. So it's giving us 19, 22, 43, and 50. And what you can also do is, since it's a dot product, you just call the function dots, and a dot b is also the same. It's giving us the same result. And another way for doing it is also you can do numpy and then dot and put a and b in it. It's also going to give us the exact same result. So you can just remember one of them. You don't need to remember all of them. And then we can also do our cross product. So basically you want to do a cross product, then it's numpy dot cross, and then you can put a and b in it. So this is going to give us a result of our cross product. So it's 2 times 2 and then 2 times 2. So it's going to give us a cross product that is 2 times 2. And also we can do transpose. We can like do the transpose of A. So we can print out the origin form. So we can print origin form and then show the transpose form. So the original form is 1, 2, 3, 4, but now it's like transpose is like just replace that in this way. So now it becomes 1, 2, and then 3, 4 instead of 1, 2, 3, 4. So that's the transpose. That's also the function in linear algebra. And also similar to list and similar to string, we also have slicing for the array. And for most part, it's really similar to our list, but something that is different is that when you want to like slice a two-dimensional list, for the first dimension, you put like a bracket, and for the second, you put in another bracket. But for the array, you can just put them all in one bracket and separate them by comma. So I'm going to demonstrate that because talk by words is a little bit abstract to talk in words. So we're going to have an array just called numpy array. I'm going to put like just 1, 2, 3, 4, 5. Probably not 1, 2, 3, 4, 5 because our index starts from 0, so it can be a little bit confusing. So I'm going to put 10, 11, 12, 13, 14, 15. The index is still going to start from 0. Wait, this is lowercase y. Yeah. So first, we can just print out an element in an array, which is just the same as list, and just do like 0 index. It's going to give us 10, and also you can do like -1. It's going to give us like 15. So it's just a normal way. And also you can do like start from 0 to 1, and the step size is defaults by 1. You can also like do 0 to 4, and the scatter is 4. So for the single dimension, it's just like really the same, but what we're going to do is we're going to do that in 2 dimensions. The first, we're going to create a list, which for comparison. So we can also do a 2-dimension list. So it's like 1, 2, and then 3, 4, and 3, 4. And we can slice that. If we want to slice that, probably going to put a little bit more, so it's going to be better. 4, 5, 4, 5, 6, and also probably do another one, 7, 8, 9. Okay, so what you can do is like for the outer dimension, you can do like start from 0. Wait. So basically, my list, and we're going to slice from 0. Wait, why this is not working? Okay. Start from 0, and then we're going to like slice probably to 1 or like to 2, and our step size can be like 1. And this is going to slice for the outer dimension, so it's going to print out the first 1, 2, 3, and the 4, 5, 6. So it's slicing like the outer dimension, but then you can also like slice the inner dimension. So you can do like we want to get from 1 to 2, and we can print that out. So it's going to give us like 4, 5, 6, because it's actually like it's not like seeing this list in 2 dimension, although like the function can be a little bit similar. It's actually seeing like it's a list in 1 dimension, but it has like 3 lists inside of it. Like we have like we get out like 1, 2, 3, and 4, 5, 6, and then we're going to get our elements which start from index 1, so it's like 4, 5, 6, and before 2, so it's going to just give us 4, 5, 6. But in array, we don't need to like put 2 brackets like this, because array actually recognize like 2-dimension array. So we can first like convert our list into a numpy array, string numpy array, and in the parentheses, I'm going to put my list. And then what we can do is that we can do array, and we can do the same. So just like this. It's fine if it's the same, but we can see that it has like more function. It's fine, it's the same, but what we can do is that we can like not do 2 brackets, but just put a comma between that. So something that we noticed that is that this is different. And why this is different is that this actually recognizes that as a 2-dimension array. So this is going to give us a row, but this is giving us like the column. And if you like just do more dimension of array, it's going to give us like that kind of dimension. So this is why like Numpy is a multi-dimension recognizing like device. So but list is not. List is just dim everything out like the elements in it. So list is itself an element. That's also probably why array can only put 1 data type, because if you put a list into array, it's going to be really confusing for the array to read. And what you can do is like the same for the row. So also you can like if you just add another, then this is going to be our start value, this is going to be our end value. End value is just to the end of the value of that column, and 2 is just going to be the step size. So this is going to be the same because we only have 3 of them. Also we can do like 1, 2, 3, 4, 4, 5, 6, 7, and 7, 8, 9, 10, probably just like this. So we can get 2, 4, and 5, 7, because we can first like print out this array to have the form not in a linear form. Probably it's going to be a little bit confusing to see that. So this is our array. We're going to also comment out our list. this is our array, and first, like, we have slice that from 0 to and start from 2. So this 2 array is what we slice first, but then we're going to slice the column. We start from index 1, so it's 2, 5, and the step size is 2, and just to the end of the column, so just all of them, but our step size is 2, so it's 2, 5, and 4, 7, and it's print out like this. So this is slice of the array, and what we can also do is that we can like do array modification, which is pretty much like the same. Like now it's like 2, 4, 5, 7, but we can like modify this number to the other. Probably like what we can do is that we can modify this value to another array. So we can do numpy array, and we can put in is that we can put a array with similar dimension. So it's 2, 4, 5, 7. We can do like 9, 9, 9, 9, and then also in this also like 9, 9, 9, 9. So we can see that we can print that out again. So print out our array again. So we replace the array. We replace this value with our new like array. So replace the number. Also, it can be different to see that much more clear. Like just like this, we can replace them, and also we can probably like change the range that we are going to replace with. So now the step size is 1. So what we're going to replace should be a array with 2 rows and 3 columns. So we can add another column in it. So probably just like this way, we are going to add another column. So now we have replaced this place. So this is how we are going to replace the array. But when you replace, you cannot put something that's not the similar dimension as the things that you're going to replace. This can be done in list, but this cannot be done in array. So list, now you have like 3 elements, but you can actually like let me change that into simple, like much more simple list. So we have a list like this. We can just put 2 things in a same place, like index. Like now we start from 1 to 2, so it's only going to be a 2 here, but we can equal to like 999 and 999. Now we are going to have 5 elements instead of 4 elements in our list. So you can see here is 5 elements, but you cannot do that in array. So I see we have one question. I'm going to check that. I'm using PyCharm, and PyCharm is, you can download that in JetBrains, and also I put that in the document. You can see how to download that. You can also use the other IDE, like you can use Repeller, the online IDE, but also you can use like Jupyter Notebooks or Google Collaboratory. It's mostly similar. It's just like probably installation of the package might be a little bit different. And we also have other way to create our array. So I've shown like the basic creation method, but also you can create that, probably you can fill an array with a lot of zeros. So what I can do is that we can do like, we can make an array full of zeros, and we're going to like let it have like 3 zeros or probably just 10 zeros. And we're going to see like how it seems. So we just get an array with 10 zeros, but also we can create an array with 10 ones. And this is an array with 10 ones. Also, we can create an array which it will fill up with random values. So we're going to create an empty array with 2 rows and 3 columns. Wait. So I actually need to put another parenthesis. So the other parenthesis means we are going to put a value in it, but what it takes is that it takes a tuple. So basically I need to put another layer of parentheses, and also we can like do multi-dimension like 2, 3, 4. So basically 2 is going to be our outer dimension, and our first inner dimension is going to be 3 of them. So 3 of them, the 3 of them, and our most inner dimension is going to be 4, so like 4 of them, and the value is just randomly generated. If you write empty, it's not the same as if you like write ones, then it's going to give you all ones like this. And also what we can do is that we can also use a numpy.arrange function to give us an array. So we can do like a range 8 because 8 is the number where we can resize that. So we can print that out. It's going to give us an array which starts from 0 to 7. It's just similar to the index or similar to our slicing, like it starts from 0 and start from the number that we have specified, which is 8. Also like our range, if you say like range 8, or like range 0 to 8, it's going to give us like 0, 1, 2, 3, 4, 5, 7, and now going to give us 8. And what you can do is that you can reshape this array. So if you reshape that, now when you create this, you can do like a shape, and you can shape that to 2, 4, or like 4, 2, or like if the array is like 36, probably you can shape that to like 6s. You can shape that to like to 18 or something that you like. You can print that out in the array again. So you can see that so this is so yeah, I need to like add a, this is like reshape. You can just do this, but if you want to like shape, it must be equals to a tuple. So print that out again. So this is working now. It's reshape into an array which has 2 rows and 4 columns, and it's in 2 dimension. Also, you can do that 2, 2, 2, so it's going to be in 3 dimension. It's also working, but something that we can also do is that we can like change it with reshape. So we're going to reshape that into 2, 4. It's also working. Reshape that into 2, 2, 2. It's also something that's working. So you can do that in either way, whether you use a reshape, or you can also use shape, a dot shape equals to blah blah blah. And so that's basically about another way of create array. We have talked about slicing. We have in the array slicing. We have talk about array modification, but we're going to talk about now is I'm going to talk about the statistic method in array. So first we can print out the square roots of the array. So can print like numpy.square. It's just square of 2. It's going to give us 1.414 blah 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 blah. You can also do the other, and also you can get the reciprocal of the number. So we can write it like probably like 2 divided by 3. It's going to give us like 3 divided by 2. So 3 divided by 2 is 1.5. Probably we can just make that a bit more clear. So 1/2 is going to give us 2 because it's a reciprocal, and also we can take the log of it. So numpy.log 3, and you can also do numpy.py, but also you can do math.py. But numpy have included all the methods in math. So if you have already import numpy, you don't need to import math because it's going to be repetitive. So you can see like this part is gray. It's not like we are not calling that. So mostly this is just so repetitive for do that because NumPy have include all the mathematical methods, but we can also like try to do like MathStoPy to see if it's working. It's just the same. So MathPy is something that we have, but NumPy is just more powerful. So mostly we just use NumPy.py. It's super useful. And also we can do like NumPy.sine, also NumPy.cosine and NumPy.tangent and NumPy. Arcsine or cotangent, arcsine or cotangent on arctan. I can just probably just copy that from my materials, so you can run that to see that if this is a choose. I'm not going to type each one in. It's like be a waste of time. We can just try all of them out. So this is getting us the result. But something that we can see is that if you do like NumPy.sine, cosine, tangent, it's taking the degree. But also like if you do like arcsine, arccosine and arctan, it's going to print out the result. It's going to return the result in radian, and put here what you put here need to be a degree instead of a radians. So what if you get a radians but you want to calculate the sine of it, then you need to use NumPy degrees to convert that into a degree. So basically what you can do is that you can do like NumPy degrees. So you can convert something into degrees. So you can convert 1 into the degree. So if it's like 1 radian, the degree should be 57 point blah blah blah, and we know that it's true. And also we can do NumPy.radian. So NumPy.radians, we can probably like just see 30 degree into the radian. So what is the radian of 30 degree? Is 0.52, and this is also making sense. So this is basically about NumPy sine, cosine, tangent, arctangent, and also degree conversion of a trigonometric function. And also we can do some like statistic function. Is basically we can write an array, just put some random number in it. Probably just 5 of them, so you can probably see, you can check whether it's correct. You can do NumPy min of this array, and you can see the result of it. Probably we're going to change to okay, I'm just going to do 4 because it's easy to calculate. So basically 4 plus 5 equals to 9, 9 plus 6 equals to 15, 15 plus 10 equals to 25, and then 25 divided by 5 equals to 5. So this min is giving us the right result. And also we can do the standard deviation. So standard deviation actually means the variation of our numbers. So the variation of our numbers is 2, but we can like make it a bit more exaggerated to see whether our standard deviation is going to be like much larger if we make it much more varied. So we can see that the standard deviation become really, really large. And also we can just get the maximum number in this array and also the minimum just with NumPy.max and NumPy.min. So going to put the array in it. And you can see that it's going to return 30 and negative 200. So that's like the basic part of the array, but about NumPy, but also you can see NumPy have a lot of different methods. So this is going to flip our multi-dimensional array. So I'm going to test that out. Probably I'm going to just copy an array here, so I don't need to retype a lot of number. And we're going to do print NumPy.flip. Okay, probably. So you have to print that out, and we see that this is flipped both horizontally and vertically with this flip, but also you can just flip not like entirely. Like this is like LR, flip LR is going to only flip the for like it's vertically, but not like flip. It's going to flip that both horizontally and vertically. And also you have another, which is our like flip. And this is going to flip that horizontally. So you can see that we have different flip methods. And also we can check what the other method of that. We also have like inserts. This is just similar to list, so I'm not going to talk about that. NumPy.linkSpace is going to help you to create an array. So we can see like what it tell us to put in that. We probably need a style value. You can check that like NumPy.linkSpace. It shows that we need a style value, a number, probably an endpoint. So can test that out. We can do like 1, then 5, and here do 2. This is going to create a new array for us. It's not going to use it. So this is just start at 1 and stop at 5, and it's going to have 2 numbers in it, or like 2 stop points. So it's gonna give us 10 stop points. Now we have 10, and the start value is 1 and the end value is 5. And also like just make 100 numbers. It's going to give us a lot of numbers, but all of them are just equally divided between 1 and 5. This is our link space. It's another way for create an array. You can also see like we have like other useful method. A pound, it's number of a pound is like similar to our list.append, and we can do a much more simple one. So we have like 1, 2, 3, 4. This is going to be clear like I'm not sure if this is going to work, but you can also like check the documentation for that. So this seems not working, but I'm going to check the documentation for this because it just have a lot of method, and usually like if you're not super clear about that, what you can do is that go to the documentation of also like I can probably like check in this way numpy.append. Is this numpy.append? What is this going to give us? Introduce for the statement. Oh, this is not. I'm going to check the documentation later for this. Also, we can check what other like methods does it have. Bitewise is something that we are not going to talk. But also, it has linear ouch, which it have a lot of function that is like really useful. So it can like just get a norm, get a mode for a vector. So you probably have a vector like this, and norm is for us to get the normalized value of the factor. So this is a norm of it, and probably you can do that like. So this is going to give us 5 because the norm of our vector, which have like 3 in horizontal direction and 4 in vertical direction, is going to give us 5. And it really have a lot of linear out function. So you can also like explore that out with the documentation. You can see that it has norm, it has invert. So probably you can also try that out. And so this is not working right. So I have never tried that out before, but you can also try that out. We have a lot for eigenvectors, and Are there any I have used? So I haven't used most of them, but I think I have like used, yeah, I think I have used invert before, but we have like determined um for a determined for a matrix, so we can like calculate the determinant for the matrix. So we can try that. So it basically have a lot of to determine. So we can see like for this, we can print out this array first. We can calculate the determinant for the matrix with Numpy. So it's basically 3 times 5 minus 4 times 4 equals to -1. So this is our determinant. We can use that to calculate our determinant all the time. I should add another for this to make this like, do I lose any? Yeah, this is fine. So get the determinant for this array is -2, and you can just try that out, and you can also look at the documentation. If you haven't learned linear algebra before, after you learn that, or like when you are learning that, you can also like look at them. Yeah, it's actually really useful when you're doing like a research in science. So I have used that before, like when I do the research in astrophysics, mostly like linear algebra, norm, which is have like used a lot. And now we're going to talk about Matplotlib after this. So basically Matplotlib, we have a plot, we have bar charts, we have pie chart, we have histogram, we have scatter plot, and we also have other plots or charts. And for each of them, we basically need to like enter the data as a list or also as a raised family, and you can like change the color, a line style, a label, or markers, and etc. of the plot and of the pie and etc. And it needs a legend, and you need a label for different bars or for different plots, and also you can you need a show function to show the to show our plot, otherwise it's not gonna show. It's really important. So we are like a bit running out of time, so I'm just going to like copy paste our data so we don't need to like waste time paste that into it. So first we're going to just import matplotlib py.plot as plt. Another way that you can do this is a way that it's useful, but also another way for doing it is that you can do like from matplotlib import pyplot as plt. I'm not sure if every IDE can do like this, but the two of them are the same. Some IDE probably will prevent you using one instead of the other. And then I'm going to like copy our value here, so don't need to input them. So basically, this is the data that I got from like the website that I've already put into the file. This is like the MIT application receipt number and the admitted number. So we have like the year. This is the year like, and this is like for the class of like 2024 or class 2030, and this is like the number of applications that received in EA and in early application, and we can draw a plot for that. So what we can do is just PLT plot, and we put the X value and then put the Y value. And then what we need to show that we need to have PL.show to show that. And now it's going to give us a plot without any title, without any bar, any legend, or any grid. So it can be a little bit confusing, but considering try to print that out. I need to share my window again. So this is the plot that we get. It's basically have nothing on that, like no titles. It only have like X and Y value. But now we are going to add we are going to add a title and also like X label and Y label. So what we're going to do is going to do like plt.x label. So our X label is yeah, and our like class is actually class instead of and plt dot y label is going to be the number of application number of early application received. And also we can add a title. So we're just going to call the title and then we can add the title. So that's going to be like the just like MIT EA status, something like that. You can name that as other things. I'm not going to like name it super correctly now, so you can start it, rerun it. So I'm running it, and probably I need to rerun it. It's a bit slow, or did I make any mistakes? Oh, so I'm not making any mistake, and now we have finished running that. So we have this window, and it's showing us the things with title and with the label, X and Y axis. Going to return to my code. And what we can do is that we can also, when we have like different plot, we can add the legend to it, but also we can add grid. I'm just going to add grid briefly. So grid is just going to give it a grid for like reading that more clearly. But what I'm going to do is that I'm going to add a another line. So I'm going to find the data of another line. So we can just compare the EA received to the EA accepted. So we're still going to have the same number of data. So each data is like corresponds with the data in the other list with the same index. And what we can do is that we can write another PLT, and this is going to called and plot that with X value, and our Y value is going to be EA accepted. In plotting this EA accepted, and this is going to just be MIT early application number and MIT EA application, and we're going to add a legend. So otherwise, you can see like it can be really confusing about which is which. I'm going to run that. And without a legend first, this is running, it's a bit slow. You probably also need to wait that for a second or not. I don't know why this is super slow today. I probably need to rerun that again. Okay, it's checking that out. So this is our EA receive, and this is EA accepted, but this is a bit confusing without a legend. The first way that we can do a legend is we can do just plt.legend, legends, and we're going to put less, which the first is just going to be like received or like EA received. Second is going to be EA accepted, because we have plot EA received first and plot EA accepted is the second. We need to follow the sequence if we use this way. So I can report that and we can show that again. So we have this, we have EA received and EA accepted, but the problem with this method is that if you have like a lot of plot and you need to remember the sequence, it can be truly confusing. So the way that we're going to solve the problem is that we're going to add a label to this. So this is going to call EA received. So even we don't remember which has been plotted first in our previous program, we don't need to worry about this, because it's always going to correspond with each. Okay, so I can just delete that. It's going to be an empty one because we have already specified them with the label. Stop and rerun. Probably it's a little bit slow to stop and rerun. I need to like completely rerun to make my laptop first quick. So this is just giving us the completely same results, but this is much more convenient to use because we don't need to remember the sequence when you have like a lot of plot. It's not going to make mistakes. It's going to like be better. We also have tile layouts function, but this is not useful for most of the IDE or like most result. It's just going to like be probably a little bit different to have really tight layouts if it's like on the website. Basically it's not making difference, so I'm not going to show you the results. You can just try that by yourself to see if on your IDE it's going to make a difference or not. And what we can do is that we can format the plot. So I'm going to show you on my Notion to see about the format. So basically, our format includes 3 parts. So we include markers. Markers is just in each like X value and Y value in that exact point. It will just mark that out. And also we have line and colors. So line just means whether it's like a dashed line or it's a solid line or it's other like dotted line or something like that. Color can be a lot of different color. It can be any color. You can use a hex code. You can also use a color name. But also for the red, green, or blue, you can just use like blue for green, B for blue, G for green, R for red. This is for the basic color, but for much more complete complex color, you use probably its full name like light green or lime or magenta. But if you want to use other, you can just find the hex color of them. Something that you can do is that I'm going to open my. So yeah, I'm going to just briefly open my Chrome to show you like how to find the hex color of some colors that you like. So yeah. Okay. Go to show my Chrome. This is my Google Chrome. And what I'm going to do is that you can just type hex color into Google, and it's a bit slow for me, for my notes. And you can just like move them like to any color that you like. Probably like this color. This color looks nice. Like this color. You can just copy the hex code here. Also, you can use RGB or the other, and the specific method for use RGB I have specified in the document. You can see that on your own. So basically, we can write color equals to the hex color that we have just printed. We have just like get. So I run this to see if this is no longer our default color. And I'm going to show the graph. So this is getting the hex color that we want. I'm going to go back to show my Chrome again. So probably we're getting another color, you know, probably like this color, you know, it looks strange, but just like going to put this hex code here, like color, and put that here, and we can run it again to see if the line of EA received has turned into the color that we have just used. So I'm going to show the graph. So let's see now, this is the color that we have just choose here. This is the same. And now I'm going to go back to my Notion. So what you can do like GC, like BGR, like for blue, green, or red, we can also try that out. So basically color equals to B. Don't need like the other, then just color equals to red, but this color is like super standard, so it's probably not that nice to look at, and we can just print that out. And this is a standard color. It's not like that pleasing for the color that we directly choose probably. But also if we use this color, and we know that our format follows the sequence of color marker lines, so we can put the color, then put the marker we want. Probably want a marker which is a point marker is just a period, and then we can put our line style can be a dashed line, so it's just like in this way. And for our other, we can just do in this way, so we're going to get a red line, and this red line is going to have the marker of a star marker, so we're going to put asterisk for the star marker, and now we're going to get a dash dot line, so we're going to put a dash and put the dot in this way, and we're going to run this again to see whether they have changed the line style and changed the marker. So I'm going to share my windows again. So we can see that it has a marker, which is a just point marker. We have the dash line, we have dash dot line here, we have a asterisk, we have a star marker, and what we can also do is that we don't need to like put them together. Put them together is mostly for like the simple color, but also it can be a little bit confusing if we just put all of them together. So like we can make things like this, and we can like specify color like this. And then we can put a marker. The marker is going to be probably a marker. We're going to try them, and then we can also put line style in this way, like line style. And what we can put is we can put a line style like this, and this we're going to just remain this part the same. I'm going to run that to see the results. So, oh, the ElevateTech color is just so shallow, so probably cannot see that clearly, but we have changed the color. It has a marker like this. It's just a little bit hard to see it. This is a part like about the markers, and I'm going to show that back into my IDE. We started a little bit late, so I'm going to like delete the end, but also if you have other things to do, just feel free to leave that. You can find most of the things in the materials I prepared. I think it's like kind detailed. We also can like add other we can add other line into it. We can have different styles. So I'm gonna show you something I have read before. So I have like add another 2 line for the RD, and all of them have like different styles, and they have different labels. So we can run that to see the results. So you can see it's like in this way, we have like different lines, and we can go back to our IDE, and we also like put different markers. So also like I'm going to just show you what I have like right before. So this I have like right different markers line style. You can see that it's like if you like choose like corresponding colors for different things, it's going to make it look clearer. So basically I'm going to show this result. So basically, we want our regular decision in similar color, but not exactly the same. Want our early application in similar color, like all blue, but not the same. But at the same time, we can like show our received data in the same line style, in the same marker. Let our like accepted data in the same line style and same markers, but not like the exact same colors. This is like going to make our rough much more clearer. And the thing that we can do is that we can also change the styles. So for the styles, what we are going to use is that we're going to do that was when I first like check the styles that is available was just plt dot. So basically we're going to check the styles available for us. So basically the plt is a function of plt. Now we're going to just choose style, and then we're going to see available, and just gonna print that out. This is going to show us all the styles available. So this is like all the styles available. We have a lot, and then we can use them. So plt dot style dot use and plt dot style and then dot use. So they use them, and I'm going to use a more exaggerated one. So the dark background is really exaggerated because it's not like white dark background initially. It's going to be changed completely. I'm going to show you the results. This is like this. And also the final things I'm going to talk about today before we probably get into other part of is that we can do XKCD. This is like a XKCD comic, so if we like run that, it's going to be like kind of cute, and just going to show that result. It's like a little bit blurry if we use the dark mode. This is terrible. So I'm going to like just turn off the dark mode to show you that. This is completely terrible. And then I'm going to run that again. It's terrible to use XKCD in dark mode, but now it came back to our regular mode, but now we use XKCD so you can see the comical effects. So basically, this is all about what we have been talking about today. So tomorrow probably we're going to get a little bit about the pie chart, but also you can read that on your own. And probably we're going to leave the time for pandas and also for machine learning part and also for our project. But that's so much for today. So if you have any questions, just feel free to ask. Thank you everyone for coming. Thank you everyone for attending this class. You ask question now, and then like probably thank you so much. And yeah, probably I don't know. It's hard like to I really want to consider about like are we going to like go to Pi or like go to like Pandas tomorrow? Probably I'm going to like launch a poll the first of the tomorrow's class to see like what's everyone's idea, but also you can send me like if you want to like hear about plt.py or plt.histogram, or that you want to probably like get more time for machine learning for our projects. Thank you everyone. Thank you so much. Yeah. Thank you. You can ask questions or you can just send me an email for the questions. You can also unmute yourself to ask the questions. Yeah, I'm going to start the record. Bye.